Hey everyone, in today's video we're going to restore this Pioneer SX-750. I bought this Pioneer SX-750 over a year and a half ago as the worst Pioneer on eBay. It was in terrible condition and it was so bad that I decided to power wash it because that was one, an efficient way to clean it, and two, if I broke it, it didn't really matter. It was worth so little to begin with. So now we're here a year and a half later. And the only things we've done to this are, of course, power wash it. We've replaced the filter capacitors in one video. We've repaired the power supply and cleaned the controls in my most recent video. So now this next video is going to be on the further full restoration of this receiver. So we'll just start with the power supply board and we'll make our way to the power amp board and wherever else we want to go next. So buckle up, it's going to be a long one. Let's get started. I suppose a good prerequisite to this video would be my How to Restore Pioneer video. If you haven't seen that, go check it out. That one's even longer than this one's probably going to be. But just to bring you up to speed, this is the only thing we've replaced on this power supply board so far. We had a failed capacitor right here. So what we're looking at now is replacing the rest of these capacitors. We're going to replace some transistors on here. Maybe all of them, honestly, because in my experience, Pioneer receivers, the transistors can be a little problematic, and I don't really want them around anymore. So if I've got a new replacement, I'm going to put it in there. We'll replace this relay, of course, because these relays get worn out. So if you've never done this before and you're restoring this for the first time, what I would recommend doing is getting the service manual out and looking at the bill of material for this board and figuring out what parts you need. For me, I'm going to go a little fast. What I'm going to do is I'm just going to pull capacitors one by one and replace them with replacements as needed, because I've got all of them in stock, I hope. So that's how I'm going to go about this. I'll show you all the old ones when we're done. Now in the last video you saw that we replaced this capacitor. This is a filter capacitor for the regulated power supply. Is it regulated? I'm not so sure actually, but these guys right here. And the original capacitor is a 330 microfarad 50 volt capacitor. But you can see right here, these actually see about 50 volts, like negative 48 right here and 46 right here. So what I want to do on this receiver is replace the one I already replaced with a 330 100 volt. And what that's going to do is it's going to give us absolutely awesome reliability. If I had to guess, this original capacitor right here, which actually you can't read it, it's completely open, it's completely failed, I think that Pioneer should have spec'd this as a 63 volt because that would have been more reliable for the circuit here. We might not have seen that failure if they had a higher voltage value capacitor in here. So I'm going to replace it with a 100 volt because I have it, and I think that's going to help us with long-term reliability here. And you'll see me upgrade the voltage value for a number of these as we go through here. That's generally a good thing to do on a power supply, especially for increased reliability. Alright, let's turn on the additional light. Sometimes this isn't good for you as the viewer, but it's much better for me. So first I'm going to start by removing the one I just replaced and its little companion here for the other rail. And if you didn't see the last video, this is super easy to get out. There's two screws that go right here, and then there's little hooks basically on the bottom here that the board hooks into. Yeah, you can see one of them. And you kind of lift it up and then you can do this with it. And this is very good because it's super easy to access all of these solder joints. So let us get started here. And I'm removing these 330s because I want to clean off that glue that you saw on the circuit board. Okay, so I've still got plenty of lead right here. I can use this for another application another time, so I'm just going to put this right back in my parts bin. Oh, whoops, how could I forget? We're still plugged in here. Even though the dim bulb is turned off, should definitely have it unplugged. Silly me. Alright, back to the board here. What I've done here is I've made sure that my pins are completely free of the trace right here. They're not stuck to it in any way, because if they were, if I did this, you'd see the traces moving and that'd be bad. But what I can do now is just go all the way like this and see. I even got some of that glue with me right there. So this glue actually might come off fairly easily. If you saw the Marantz 2230 that I just restored, that glue did not come off easily at all. Yeah, see, look what I can do here. I can peel it off in very small pieces if I'm very careful. And maybe get a bigger piece if I'm lucky, kind of like that one. But if you can't get this stuff off, acetone is what dissolves this easily. Even a little flathead screwdriver like this one can help sometimes. You just got to be careful you don't scratch your circuit board if you're going to go about it this way. Which I am scratching this one a little bit, but, you know, this thing was power washed. No one wants it. It doesn't matter. If you're trying to make money doing a restoration and trying to sell this for, you know, $5,000 when you're done, you should probably pay better attention to how you're removing this glue than I am. Now, one thing you'll notice on Pioneer receivers is that all they give you is obviously these little terminal numbers, but they don't give you the component number on the actual circuit board. All they give you is the component orientation, the proper orientation. So because of that, what I like to do with Pioneer is I like to just kind of replace things one by one, because you'd have to go into the service manual and look at a very unclear drawing to find out what's actually on the board, and that's very annoying. So what I'm going to do is I'm just going to populate these as I finish them. And then, of course, if you're going to be putting see, this doesn't really want to go in, it's probably because these joints under here, there's probably a little bit of extra solder. I'll bet you if I put this right here, it'll start sliding through a little more easily. That old solder is kind of collecting around the old joint there. Yeah, see? So sometimes you just got to kind of heat it up, and you can have a little bit better luck putting this thicker lead through that hole. Yeah, the leads on these new caps are quite thick, and they're having a hard time making it through this circuit board. Alright, finally got that through. We'll just go right ahead and solder those in place. Bend them back like that. Grab your solder and your soldering iron. Flow those joints with some nice fresh stuff. Let's trim those leads. Yeah, those won't be a problem, I don't think. And look, most of my scratches are covered up anyways, so it's all good. Let's move on to these caps right here. And that's going to be these solder joints right here. Let's get this one first. What do we got here? Gotta heat up a little more. This is a 50 volt 100 microfarad capacitor. I'm noticing this one has like some weird burn mark on it or something. So I'm going to throw this on the capacitor tester. We'll just connect this right here. We'll go right here. Yeah, see, this is why we recap, folks. Let's test that 330 we just pulled out and see what kind of condition that was in, because you know its mating capacitor had completely failed. Yeah, see, we're at 231 microfarads, and it's supposed to be 330. That is so far below the acceptable capacitance. This is why we recap. And on this one, this is a 150. Since it failed, I have some 163s. So I think what I'll do is I'll throw a 163 microfarad in this capacitor's position. Before I do that, the one right next to it is the same capacitance. So let's pull that one and check it out. This one looks like it's about to explode. There's actually a crack in the base right here. You don't normally see this aluminum ring right here. You can tell like it's not in good shape. Let's see what's going on with this one here. Alright. See? Look, another dead cap. There's nothing here. Those are each 100 microfarad 50 volt. We're going to put 100 microfarad 63 volt in their place. It's pretty unbelievable how many failed capacitors we've seen already. And this isn't exactly common either. Like, generally, when I work on this stuff, Most of the caps I pull out are okay. I will say this has been a unique example so far. I mean, we've only pulled we've pulled 8 capacitors out of this thing. This thing was well loved and very, very abused, I guess. We're going to keep going here. We're going to see what else we find. Alright, where should we go next? How about these 3 down here? Let's get these 3. 2 of them are 220 microfarad 16 volt, and one of them is a 100 microfarad 35 volt. Let's go for that 100 microfarad 35 volt. Let's see what we've got going on here. Is the board marked correctly? Yes. 35 volt 100 microfarad. This one looks better than most we've seen. And this one measures at 83, which is very close to the bottom of the 20% tolerance. So here's a 150 volt in place of the 135 volt. This will be great right here. Now let's get these 220s out, see what they're all about. This one looks a little suspect. Let's see how it goes. Okay, 137. It's supposed to be 220. Not good. Not good. And 124. Even worse. Even worse. Alright, we have 220 microfarad 25 volt replacements right here. We'll throw those in, making sure we are orienting them correctly. Yeah, let's open up that joint there for this lead. Come on, there you go. And do one more. Does it need the same treatment? Yes, it does. Not too much though. There we go. Bend your leads. And let's get these all soldered in. So I think you get the name of the game here. Recapping is just a slow, tedious process. And you don't need to test everything, but I'm just showing you, like, on some units, everything's bad. Alright, I'm just going to keep going here. I'm going to get all the caps done, and I'll come back when it's time for transistors. Okay, all of the caps are replaced, but let's take a look at what happened right here. See that loose wire? Not a good thing. And that's what you get when you, do this kind of stuff. Like, I'm being a little bit careless with this, and that's just something you need to be ready for happening. So the way you fix this is you cut this end off, you strip it, and then you just kind of wrap it around this post again. And hopefully you've only lost one, so you know exactly where it is. If we lost 2 of these, I'd have to look back at the video and see, or if you were smart enough to take pictures, you'd have to look back at that. But as you can see, all of our caps are replaced. They were all electrolytics originally, but these 2 right here, these are part of the protection circuit. I replaced them with films because I didn't have electrolytics that small of a value. This is just what I had on hand, so there's films here now. What I'd like to do at this point is I would like to turn this on and see if everything is okay. And I want to do this before I touch all the semiconductors because this is going to be a little bit clearer now than later. So let's go ahead and put this on the dim bulb and we'll turn it on like so. There it goes. We'll probably get a relay click. Yep, we did. What I'm really looking for is any of the capacitors beginning to bulge. And I've actually seen this before when I've made a mistake on a capacitor polarity. Hopefully I got everything right, and it appears that I did. Now this purple wire, it actually goes to the speaker output. So one of these channels is not going to work anymore. Let's see. It looks like I still have speakers connected actually. So if I were to go to FM, I should get sound out of one channel. And I do. So that's good news there. Let's see if I can get a signal out of the radio. Let's get some antenna action going here. FM radio's in bad shape. We're not getting anything. So that is a concern. We know something is very wrong with FM. We'll have to get that later. Anyways, it appears the power supply is working. So we're going to call that good, and we're going to move on to the semiconductors. So what do we got here? We've got 1, 2, 3, what you call TO220s. That's this style right here with the kind of heat sink looking thing on it. And then we have 1, 2, 3, 4, 5, 6, 7, 8, 9 TO92s. This one's not exactly a TO92, but we're going to replace it. Let's start with these guys right here, these guys in the heat sink, because these take a lot of heat. They do a lot of stuff. Like these heat sinks are already warm just on that little amount of time we spent with the receiver turned on. So the way you take these out is first undo these screws right here. And we're going to do these one at a time because we don't want to screw up the heat sinks. You know, obviously this one gets hotter than this one. So you can see they're a little bit looser now. Then we're just going to take the desoldering tool and let's get this undone right meow. There you go. So this is our first one. Let's throw it on the semiconductor analyzer just for fun. Here we go, analyzing. It is a good transistor, base collector emitter, and a gain of 54. I don't know what the range is on this transistor, but that seems a little bit low. So a good replacement for the 2SD313 is the MJE15032G or a KSC2073. I don't know the current rating for this one, but I think this one goes up to like, I don't know. You can look up the data sheets, but like this is going to be great. And I believe it's the same pinout. We'll check that with our semiconductor analyzer. That's the DCA55. Should say it's an NPN, and it does. It should be BCE. It is. And the gain is 92, a little bit higher than what we had before. So now let's work on swapping it out. So now we need to remove this transistor from the heatsink, like so. Screw shouldn't be too tight. As you can see, we've got this thermal compound here. We're going to want to take a paper towel and wipe that off. And then we're going to take Dow 340, this stuff right here, and we'll put it on the transistor itself. Just going to go like this. Don't need very much. I didn't even squeeze it, I just kind of tapped it against the transistor. And then we'll go ahead and just kind of smear that a little bit where we want it to be. Got a little more than I need there, but you know, that's okay. Then we'll take our screw, thread it back in carefully. Doing this left-handed, huh? I am not left-handed. And now here's the part that's kind of important. You know, you gotta tighten it, obviously. You see it wanting to turn. So what you'll do, you'll hold it with your non-dominant hand. And make sure you've got the leads straight like this, and then tighten it. You'll feel the transistor kind of go into your thumb as you're tightening, and then looks like you've tightened it almost straight, so yeah, not quite. I gotta try that one again, so I gotta undo, make sure I'm straight again, and then try and tighten again. I think that'll do it. There, straight-ish. Okay, and then we've got our excess thermal compound. We'll just kind of take the paper towel that we used earlier and wipe off along the edges there. Make it look a little clean-ish. And then, since we're going into this board and we got like a triangular pattern we gotta hit here, we're gonna take our pliers, we're gonna grab it like this and just kind of move out like so. Just like that. And that's gonna allow us to set into the board nicely. Remember our orientation. We'll get our base and emitter in, and then the collector kind of falls into place. I guess I'll move the camera and show that from this angle. You can see, look how nicely that sits in there, those leads. I got that bend really good there. And now, this is very important that you do this first. You want to screw it back in to the circuit board. And the reason you do this first is you want to make sure that your solder joints are exactly where they need to be. So yeah, not too tight, just tight enough to where it's snug. Not too tight. So now imagine if you were to do this right now, and you hadn't tightened your screw. You're soldering these leads onto this board, and then this is all solid and, you know, cooled. And then you go and tighten that screw. Well, guess what's going to happen? You're going to put strain forces on these solder joints here. And that's not going to end well for you. You're going to damage your circuit board when you do that. For these joints, you also want to make sure you use a good amount of solder because, as you know, this thing gets hot. And the more metal you've got on that joint, the better it's going to do with the heating. I see we've got some thermal compound on the end of the screw. I'll just get that real quick. That's how you do that. Let's get this one next. I believe it is the same kind of transistor. Okay, there we go. Now you might notice the pattern here, you want to pull your collector out a little further for this one than this one. We don't really need to go out very far, so we're going to keep that in mind when we do our bend. But, yep, it's another 2SD313. We're going to replace it with the same thing, a MJE15032G. We have one more TO220 right here, so I'll go ahead and pull that real quick. Let's see what it is. And out. Let's take note of the orientation. This is a 2SB507. That's going to want an MJE 15033. And this one doesn't have a heat sink, so we're just going to put our bend in it and go straight into the board. Okay, so I've got our 3 TO220s done. Now let's work on these TO92s. So just reading the components, we've got 1, 2, 3, 4 at least. What's that one? Oh, 5. 5 2SC 945s. Those are easy to replace. They're replaced with a KSC 945. And I've got a whole bunch right here, so I'll get 5 out. Okay, so we're the emitter collector base pinout on here, as you can see. So what that means is, like, if I look at the flat face right here and I read the pins, we are emitter collector base. You see red, green, blue. So let's pull one of these C945s on here and see where we're at with these guys that are actually on the receiver. So it could be different, which means it's going to break my brain getting all of these replaced. Okay, so here's one that I just pulled out. We are ECB. Perfect. I love that. So that means that as long as the board is marked correctly, which looks like this one is, I can put these in how the old ones were. And that makes my life so much easier. Okay, so I've got the 5 945s replaced. Now I'm looking at these two right here. These are 2SC 1649s, and this yellow paint right here makes me think that these might have been matched from the factory. These are part of the protection circuit, and a quick Google search of what to replace them with came up with KSC 1845 being a good potential replacement. What I've got here is my collection of 1845s. They're a little bit higher gain than this, but in protection it might be okay. So what I'm going to do is I'm just going to choose 2 transistors that are of the same gain here. So looks like I've got a 415 and a 415 right here. So that's what will go in place of the 1649s. So we've got 2 more. We've got this one right here, a 2SA823. I'm not finding a clear replacement for this one, and it appears to be okay, and it's not causing any problems, so I don't really want to go down the path of like figuring out a good replacement for it. This one right here for the protection circuit, this is a 2SC1166. The service manual says 1167 or 1384. KSC 2690 should work well right there, so I think that's what I'm going to do there. Because that is what I have on hand, and that is what the internet says will be okay for me, so I'm willing to believe that. It looks like I've already had this one somewhere before. So yeah, I'm leaving this one alone, because I think it's going to be just fine. Alright, so there's that. Got all the transistors replaced now. Let's once again give it a little test and see if it all still works. do we get a relay click? We do. Do we get sound out of FM like we used to? Yes, we do. So, that's a good thing. It appears to be working as it used to. Now, the last thing I want to do on this is replace this relay. And I'm going to do this wrong. And I'll tell you why. What I have here are a bunch of these MY2 relays, and they only have one set of pins here. This one has two sets on the inside. You can see on the back we've got a whole bunch of solder joints right here. And really, this is all we actually need, is these. This is a lesser quality relay, or it's not as good, because like if you were to look inside of this, you'd have 4 of these guys right here, 2 per channel. Looks something kind of like this, right? This isn't the right pinout, but this is the right kind of relay. So if one of these fails, you still have the other, and the audio can get through. This is not the right choice, but it's what I have on hand, and it's what I'm gonna do. So yeah, you can see we've got some extra pins here. We're going to need to chop these off so we can get this sitting flush on the board, but then we should be okay. And then what we'll do is what Pioneer did from the factory. We'll take this pin and we'll bend it down like so. Then we'll take this pin here and we'll bend it down. What that's going to do is it's going to allow us to get this thing to sit stable on the board, kind of like this, while we go ahead and solder it. So let's do that now. And even though we only have these pins, we're going to still lightly seal up these open joints here. And that's just good practice. So there's your power supply board. Let's try that one more time. See if we get a relay click. And we sure do. So we've got a fresh relay in there. This power supply board is done. We just need to reattach this wire, obviously. So the way we do that is we kind of pull it out. See, we got plenty of wire left. It's not a big problem. Chop that off. Take wire strippers. We'll strip the end, and then we will wrap it around this post here. Once we're wrapped around, we'll kind of give it a little pinch to get it tighter, and then we'll add solder. Oh, sorry, I wasn't zoomed in for that. So now if we take this and try to play everybody's favorite song, it should work. Very nice. So that's fantastic. We've got ourselves a freshly rebuilt power supply board. Look at those nice new capacitors, brand new relay, new semiconductors, well, minus that one. And everything seems to be in great working order. What do we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 caps on that power supply board. Some of that belong to the protection circuit. We got the relay, we've got these semiconductors here. This is a good thing we did here. About half of these capacitors that were related to the actual power supply were bad. So it's a very good thing they're out of here, and we've got nice new proper stuff in here now. So now I think it's time we move on to this back here, the power amplifier board. There we go, camera. Alright, power amplifier board time. Let's see. I think we're going to get to this one by starting from underneath. We need to disconnect the output transistors from the circuit board. So, I'll show you right here, we've got little connectors. All we're going to do is just pull each one of those out, but just in case I get a little messed up here, what I'll do is I'll put 1 dot here and 2 dots on this one, 2 dots on this one, and 1 dot on that one. And that way I know which one goes where. So our 2 dot ones are in the middle and our 1 dot ones are on the outside, and they go to whatever. Easy. So let's do this. And they are out. And it looks like we'll want to undo these guys too, and we're going to want to be really careful with those. the entire time. Because if we break these little leads going to these guys, we're in trouble. They're open at the end, so we can just undo the screws and then kind of lift them out maybe. Well, actually, that just increases their chance of breaking the leads. So let's just take the screw all the way out. Nothing wrong with that. Next we'll come back up on top and we will undo the screws that mount the power amp board to the heatsink. So there's one here and then one on the other side. And then we're going to undo the screws for the heatsink. There's 4 of them. I bought this screwdriver because it has a magnetic tip, but it doesn't work very well. We'll use the JIS one like we're supposed to. Okay, now what we're going to be able to do is we're going to be able to move this amp board slightly forward by lifting up, taking it out of the little things it sits on. And then we should be able to... Oh, there's 2 screws in the back for the heatsink also. We should be able to lift the heatsink up out of the unit after that. This looks like it's going to be a little tight and maybe a little bit painful, so need to be very careful with this part. I'm going to go on the side. Wish me luck. Okay, so what I was able to do is kind of push the amp board up and toward me, and that created enough room to kind of squeeze everything out. And I'm watching my connectors and these guys to make sure they don't get snagged. And here is your heatsink. So now we're going to be able to replace the mica insulators on these output transistors at a certain point. I think I'll do that after I restore the power amplifier board. So taking a look at this board, what do we have here? It looks like we've got 3 electrolytic capacitors per side, 1, 2, 3, and then 4, 5, 6. We've got these 5-pin transistors here. These are basically your differential pair. We have 2 tantalum capacitors right here, and we have this 1 transistor right here. So I think I'll be replacing just those. The driver transistors, they're on these heat sinks. I think they're going to be just fine. I haven't seen any issues with them. And that'll be the power amplifier board. Alright, so here's the game plan for this. We've got a few caps and some transistors. So you can probably see on the board for the differential pair right here, they have this like double PNP thing going on here. It's got 5 pins, but it's 2 transistors in there. So what we can do to replace those is we can actually take 2 KSA 992s, make sure they're matched. As you can see, I've got the gain written on all of these. I test them when I get them. So I'm going to get 2 matched pairs out of here, 1 for each channel. The bias transistor, it's a 2SC 1438, I believe. I can't quite find a clear replacement for that, so I'm going to try out a KSC 2383 and see what happens. If it doesn't work, I'll know I have to go back or find a better replacement. And then for caps, the blue tantalums, that's the first capacitor in the signal path. We're going to use some alnisilmic 2s for that. We could use films, but you know, I'm going to try electrolytics this time, see if I can hear a difference. Then for the other caps, they appear to be just general electrolytic capacitors that you do power. We've got 2 220 6.3 volts, so I've got some 220 10 volts to replace those. And then we've got 2 135s, and here's 2 150 volts. That should come PW. Alright, so I've got one of the differential pair guys out, and just out of curiosity, I want to see if when I test it I get a matched pair, because I'll bet you these things have drifted after a little while. So let's see. When I test one side, I get a PNP, of course, with a gain of 392. So let's switch our leads to the other side. Test it again. Yep, another PMP. And 385. So it's actually pretty close, but for reliability, it's going to be better if we replace it with two of these guys. So I saw some 392s on here actually, so that said 392, and then this says 392. So these will be our thingies here. And it looks like the emitter is what was shared. So these transistors are ECB, so we're going to want to make sure we join the emitters on these transistors, and then we could put some heat shrink and thermal compound on there, and that'll give us a replacement part. Okay, so I've got some assorted heat shrink tubing here, and we'll see what size fits over it nicely. Instead of getting scissors, I'll just do this. Maybe I should have gotten scissors. Gotta do the job right. There's one, and there's two. Let's take this off a little vise here. Just kind of lightly clamp them into place in the vise. I'm going to solder the emitters together real quick, like so. So there we go. We've got some solder right there. Now we can take them out. You see they're kind of held together a little bit. We can add a small amount of thermal compound. Probably should have done this first. Let's get creative and use a multimeter as our tool here. And now we can take the heat shrink tubing. We'll just slide that right over. Then I'll grab a lighter and make this happen. Heat gun is obviously a better tool for this, but this is much faster for me right now, and if you're careful you get the same result. So there's that. Now we've got these kind of bound together nice. And what we can do is arrange the pins how this guy's pins were arranged. So we have the common emitter. Let's have that kind of coming out toward us, and it is. And what I'm going to do is I'm going to snip just one of these and leave the other, and that way we can bend this one like so that we're out. Then we'll bend the bases out, and then our collectors kind of like this. So see how that's going to sit in the receiver really nicely? Let's go ahead and throw that back in the amp. There we go. There it is in there. That'll work just fine. Then I'll just do that exact same thing on the other side. Alright, now it's time to dink with this heat sink here. We're going to take off these transistors. What we're doing here is we're just removing them. We're going to apply thermal compound to new insulators, and then we're going to put the transistors back in. It's quite simple. I suppose we can do them each one at a time, just to keep things nice and simple. See, there's your old insulator. We're going to throw that away. We're going to get on a new one. While we're at it, we'll set up our workstation. Got our applicator. Got our smush right there. That's about all we'll need. Not much. And get another paper towel. One for cleaning off the heatsink, the old stuff. We don't want this here. We do not want this here. And we'll want to clean off the old transistor too. So, get ourselves 4 new mica insulators. This is Mauser part number 4636. That's the manufacturer part number, but if you type in 4636 on Mauser, you'll find these guys. First thing we'll do is we'll just kind of get this going here. Stir it up. And let's begin by applying to one side of the insulator. I'll show you why we only want one. Because what we're going to do is, instead of applying to the other side of the insulator, we're going to apply to the transistor itself instead. So that's done, nice thin layer. Now let's go over here. Apply to the transistor, making sure we do not get any compound on the leads. Now that we've done that, we'll take this insulator, and it only goes on one way. We will put it wet side up, like so. So now the dry side of the insulator is in contact with the wet side of the transistor. And then, once we have it that way, we'll just stick it right back in the amp. And you do it that way because you don't have as much mess when you're done. And then back here we'll need to figure out, I think we might take this back cover off for ease of maintenance here. And there, now you can see we've got this thing. This is what you got to plug back into. So just make sure your pins are lined up. Get it in there. And then you can re-secure the transistor to the heatsink with these long screws here. And you just do that 3 more times. There you go. All nice and re-thermal did and stuff. Let's put this cover back on, and then we can put this back in the receiver and see if our transistor substitutions were a good idea or not. Alright, I got that all reassembled. This is the nerve-wracking part where I plug everything back in and see if I made a terrible decision with my transistor substitutions. So let's go ahead and throw this on the dim bulb and turn it on. No shorts, so that's good. Still relay click, that's even better. I want to say that happened faster than it normally does. So now what we got to do is check for DC offset at the speaker terminals. And yes, I did clean off the tip of my probe, so let's see. On the left channel, 24 millivolts, not amazing. On the right channel, also 24 millivolts. That is very oddly consistent, but it's still a healthy number. I believe the SX-750 does not have a DC offset adjustment, so we're just going to have to live with that. That at least means I did something sort of right here. Now let's go to the service manual and figure out how you read the bias. Alright, so for bias it looks like you go on the underside. You need to check across pins 1 and 6, and then pins 11 and 16. So that makes sense. So let's find those. Let's try 1 and 6, see where we're at. We're at 25, which is about what it's supposed to be right now. And then for 11 and 16, let's check that. We're at about 28, which is again about where you're supposed to be. So far, it appears that the KSC 2383 is a suitable replacement for the 2SC 1438 in this particular application. We'll see how it sounds now. I'll do the full adjustment when we're done here. Okay. Sounds good. There's some muddiness in the bass, and I'm hoping that that can be addressed with the preamplifier restoration, because like, I don't know if you can hear it, but I can hear just like a general like grossness, I guess, in the bass in this song that I don't normally hear. Alright, let us continue with the preamplifier board. It's right here, but we need to remove this shield in order for us to gain access. Alright, that comes out like that. We need to figure out what size socket it is. Is it a 13? Maybe? Yeah, it is a 13. They're just loose as heck. Could be a 12. I don't know. We'll find out when we tighten it. And then we're going to undo some screws on the front of the receiver. Yeah, real goofy how they've done this. Okay, so I was removing the wrong screws. You really only need to take out the two that the toggle switches are secured by. And there, you've got some access to this dang thing. Alright, so here's what we got going on here. We've got 8 caps, and we're going to want to replace all 8 of them. These two right here are 4.725s. They're going to be replaced with an audio grade. These two right here, these are actually the first caps that the signal goes through. They are a 0.47 microfarad, 25 volt. We'll get some audio grade ones in there, or film. And then, right here, we've got some just standard filtering guys. These are 220 35 volt, and these are 106.3 volts. So just nitpick on PW for these black ones. Alright, we've got our new 220s, our new 100s, our new 4.7 audio grades, and our new 0.47 audio grades. So I'm going to just get right to this. Alright, got that done. And the other thing I did is I tightened the nut on the speaker selector switch. When you've got it apart, you can kind of see there's a nut in there, and I just stuck a 13mm in there and just kind of gave it a little thing. You can kind of pull all this out. Makes sense when you're in there. And you may recall this was really loose before, and now it's not. It's much more solid. So I really like that. And of course, we've got our 8 capacitors right here. They all tested not terrible. So now what I'd really like to know is that now that I've replaced, I think, all the capacitors in the signal path, I want to know if the bass still sounds muddy on Walk Through the Park. It does sound a little tighter. Yeah, I'll take it. Alright, I was just playing around with this thing a little bit. I want to show you some absolute insanity. So, before I started playing with the tuner board, I wanted to see if I could figure out like why the tuner's not working. And I didn't figure it out, but I figured out some weird stuff. So as you can see, we're not picking up anything. And even if I hook up an antenna, we really get no difference at all. The AM works, actually. There's a station over here that worked. So, yeah, AM radio works pretty well, actually. But FM does not. So what I was doing is I was just checking voltages on this thing, you know, the service manual. We've got power going to everything. That's all good. So I decided to start at the front end. And I got to this transistor right here, and I started checking voltages at it. I looked for this 2.2 volts at the base of this thing. And I want to show you what happens when I put my multimeter probe on it to see if I have the 2.2 volts. So first let's hook up to ground so I can actually see the 2.2 volts, and watch what happens when I touch the emitter of this transistor. FM starts to work perfectly. And if I just clip this thing to the emitter of that transistor, FM works great. See, I can go through different stations. And it's actually pretty accurate what the stations are that I'm going through. So, I do not know what's up with that. I tried putting a 1 mega ohm resistor across that base and ground. That didn't fix it. It's only the multimeter that will allow it to work. And I do not know why. Alright, it's been 3 weeks. I just worked on this a little bit more. Please forgive me. I restored the tuner board slash phono preamp slash whatever, you know, this big board right here. The phono preamp, you've got some capacitors back here. You had some tantalums, I replaced those with LNS Silmic 2s, and then some regular capacitors that's just got to be replaced with PW. And then you've got the tuner section all around here. Forgive me a second time I got lazy with the tantalums. I'm just wasn't really feeling it, and I've never seen one fail. So normally you replace those. I did not this time. There's 2 caps in here for the microphone section, and I can barely even show them. They're so tight in there, but I was able to get to them and replace them somehow. It's very difficult. I was also able to get these guys right here without removing the tuner string, so that was an achievement. But back to that tuner issue I was having, where I showed you if I just put my multimeter on the base of that transistor, or was it the emitter? I don't know. It was that one right there, I could get it to work. So I started troubleshooting that a little bit more. I just started checking voltages, and like everything looked fine. I was getting nothing with an antenna hooked up. And then what I decided to do is just start moving all these little coils in here. You know, these guys, these are what you adjust for the FM alignment. When I played with this thing right here, not sure what that is yet, but when I touched it and turned it a little bit, I was actually able to get it to pull in stations once again. So there it is. It's not working fantastic or anything, but it is working. And it did not do this before, so I'm pretty happy about that. I think the last thing I'll do in this video is the lamp replacement. So that's going to be these 3 incandescents up here, and then we've got 6 indicator lamps. That's all there is to this receiver. Now I got my lamps from Dave, dgwojo.com, like over a year ago, and that's what we're going to be using here. So to get these guys out, pretty easy. You just kind of yank them out of the housing here. I used good rubber here that is held up to the times, and it just kind of comes right out. Now it looks like I did not have the leads soldered onto these. We're going to have to do that ourselves. And I think a nice easy way to do that is we just cut these as short as we can. Here's what I'm doing. I'm just trying to slide the bulb out of the thing here. Yeah, there we go. You can see Pioneer did these like little crimp things. And this is what we saw on that MCS 3233 as well. So let's go ahead and start with this middle one here. We've got our fresh bulb here. It's what we need. Let's go ahead and snip this as short as we can. Alright, like that. And then we will strip these leads here. So what I'm doing is I'm kind of bending the leads down on the bulb and then sticking my wire through and then wrapping them around in a way. Maybe I'll be able to show you a close-up when I'm done. I think I'll start right here, see if I can get this hot enough, and get some solder on there. Okay, looks like that one was actually successful, so that's good. Yeah, moving close, and I'll set it to manual focus so it stays the heck put while I do this. Let's clean the tip. I'm going to hold this here for just a second, get it as hot as we can before we start adding the solder. Then we can kind of go in carefully. You might be able to see we're not really getting good, I don't want to call it penetration, that's a welding term, but you want the two sticking to one another, right? So like, I'm taking this, I'm moving it, and it's staying as one. So now what we can do is we can just shove this right back into this rubber boot thing. And then we can go back under and feed it on through. Let's take a quick look at that and see if that worked. Do we have light there? We sure do. So yeah, that was successful. Let's do that for the other two. Alright, so there's your three main lamps. I'm going to leave this one out for just a minute because down here are the indicator lamps. And the way you remove these is you just kind of try to yank them out. Sometimes that works. We'll see if it works this time. I hope it does because that's easy. So here is the AM lamp. If I just pull, it does come out. That's a good thing. So we're going to take care of these one at a time actually, so we can keep track of what we're doing. Okay, so we're going to need 6 of these guys here, and as you can see, it's the same size. What we'll end up doing is we'll just end up putting it straight back into the little housing here. This is like a softer plastic, so it just kind of slides right in, not too bad. So there's 2 ways to do this. You can either cut each one and splice it in, or you can take these wires and find where these connect to the receiver and then just put these on in their place. So I think I'll take that approach with this first one and see how I like it. So as you can see, here's your 2 wires right here, and we can see one of the wires goes down to the board right here. So I could just rip this off actually. That's pin number 5 near the selector switch. Needs to be about this long, so I'll cut right here. I'll strip it. Probably should have done that last. Yeah, should have done that last because I got to run it through all this stuff now. So we can run it through this wire way. Then we have this zip tie we can run it through. And then down here at the board, I'll zoom in on that. You can see pin number 5 maybe. It's right there. So I'm just soldering directly to that post there. I think what I'll do actually is I'll go like this. I will wrap this around my screwdriver like so. So now I've got this nice little ring here. And then I can just set that into the post. And then I can go in with the soldering iron and solder it to the post. Okay, so that's one end. And the other end, where does that go? That goes to the power supply board, is that right? That's the one. So we're going to chop this off of the power supply board. Now we can remove this entirely. Then we'll get our new wire length and strip. And we'll put it through the zip tie to be clean. Maybe I'll just put a new one on later. You just solder that, but I see another wire on it that's going to be for the FM indicator lamp, so we can just not solder that yet. work on getting the FM lamp out, if we can. Okay, yeah, then sometimes that happens. You just totally screw up and, yeah, pull off the wires. And then you're in big trouble. This is why I really don't like doing these. Okay. Alright, we gotta take this apart further because I just screwed that up. So we'll remove the top plastic here. It looks like we've got these two right here. Maybe this will get us where we need to be, I'm not sure. Okay, yep, got that off. And this should, oh, I don't know. What should it do? Let me know in the comments what it should do. Okay, I had to do that now so I can push this bulb out. Okay, so that one came out. This one came out. So that's just the FM one. Let's take out our new AM for now. And let's carefully convince this lamp to leave its home of 50 years. I'm just going to try and push it through. Yep, that worked. Got it through. Now we have to get the heat shrink off. And that's off now as well. Okay. I'm going to need to vacuum that out, that's for sure. Put this back in for now. This metal piece just kind of held it in place. So it should go back together, hopefully, without too much drama. Yeah, it's basically just a large retaining clip. What did we learn here? We learned be a little more delicate when you're trying to yank those lamps out. And that's about it. Okay, where were we? Now we have this lamp. Did I like doing this before? That looks awful to get to. Let's do one splice and one solder onto there because I have to undo this one already and attach two different bulbs. So let's get this out of here. And now we can take the soldering iron and put them on there for good. And now we can do our first splice. I think I like cut the red a little bit shorter, and we will cut the white around here, and we'll strip each one. And before we even consider the splice, we need to put a piece of heat shrink tubing on there so we can melt that over everything when we're all done. So now what I'll do is I'll just take these wires, kind of wrap them around one another. The Pioneer wire is much thicker and heavier than this new wire, so that creates some challenges. Okay, so there it looks like one wire right there. Now let's just take our iron, very carefully add some solder. And there. That's a splice right there. See? Pretty strong. Slide this over it. And then we'll light it on fire. I'll do it this way, now you can see. And there. Now we've got the stereo and AM lamps replaced. Now we just have the phono and aux lamps to replace. Then of course we got these two over here. I'm going to stop recording because I already have, I think, 40 minutes of video into this already. As you can see, it's quite tedious, but it's more or less straightforward. Alright, that's all done. As you can see, we've got new lamps all over. I decided to run the wires for most of them. I made 3 splices. You see them right there, because it's just kind of difficult to solder in that little area down there. You know, it's a little tight. But up here on the power supply board, pretty easy. So now we get to see if I made any mistakes. So let's try this out. Turn that off so it's easier. Around the dim bulb, turns on, great. Looks like we have a power light, and we have indicator light. Let's see, do we get AM? Yes. Oh boy. I screwed up the aux and phono lamps. That's hilarious. Luckily, I think I've got enough wire. What I'm going to do is I'm just going to switch them. So I just pull the one out and the other one out. Right, yep. I put this one in there, and I put the other one in there. Simple, easy. Yeah, plenty of wire. Okay, how's that now? Much better. And yeah, those 3 lit up there. It's going to make this thing look a lot nicer. So I'm going to wrap this one up right here. I think we've shown quite a bit of in-depth stuff here. Next video, we're going to look at FM alignment. We're going to look at doing tests, see if all the audio stuff works properly. FM alignment's very important, obviously, because we can't. I don't even know if my stereo indicator is working because oh, there you go. Yeah, okay, so it needs an FM alignment because I just played with all of those completely arbitrarily with nothing connected to it. Yeah, that'll be in the next video. And then of course the power washed Marantz 2230 needs a similar treatment. And speaking of the power washed Marantz 2230, we've got a new product to introduce in the next video you see on that. This is a new dial pointer for Marantz 22 series receivers from vintagehifiaudio.com. They're for sale right now if you're interested, but I'm going to show it more in depth once we get back to the Marantz 2230 and wrap that receiver up. So just thought I'd put that out there. He sent these to me last year, end of last year, so I owe Aaron a video, so we'll get there eventually. Thank you all so much for watching. I hope you enjoyed this long form video, and I will see you in the next one.